Thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello, everyone. Thanks for tuning in to the Concentrator Talk, brought to you by the Oxygen Alliance. So this is week 27 of our course. So joining me today on the call are my colleagues, Amaprid Rai and Mteto Sinjani, along with our usual technicians from OpenO2 and Sunrise. So on the technicians panel today, we have Masofa Mujaji and Paulina Mohosho joining us from Johannesburg, South Africa. We have Kuinda Singh joining us from Chandigarh, India, and Francis Sambani, Daphne Magela, and Linda Mishoni joining us from Lilongwe, Malawi. So in case it's your first time joining the call today, the Concentrator Talk is a virtual meeting that we host every Thursday from 2 to 3 p.m. Central African Time. And here we discuss the different aspects of concentrator assessment, use, and maintenance. So if you have some issues with the concentrator that you need help with, please don't hesitate to get in touch with us through our email address, info@oxygenalliance.org, and our technicians will do their best to assist you. So normally during the call, we also have topic of interests, and today we'll be talking about what not to do when you're using an oxygen concentrator. We also have pause at the end of some of the questions, so please attend to them when they pop up. Right, so now to jump onto our questions for today. So our first question says, I was going through the service manual of a Vilbis oxygen concentrator, and it says that I shouldn't leave the sieve beds exposed to the outside environment. Why is this so, and what may happen if I leave the sieve beds exposed? So I will ask Masofa to respond to this one.
Thank you, Mari. The lifespan of the zeolite reduces when sieve beds are left exposed to the outside environment. This is because humidity and dust in the air contaminate and reduce the absorption capacity by blocking the sieve walls on the surface of the zeolite, thereby decreasing the level of oxygen purity delivered to a patient. These sieve walls are designed to allow oxygen molecules to pass through by holding back the nitrogen molecules because of their size. Zeolite is hydrophilic and has a high affinity for water. When the zeolite is exposed to air, it absorbs moisture until it reaches a saturation point. When this occurs, it loses its ability to absorb nitrogen. Zeolite being hydrophilic means it has a tendency to mix, dissolve, and get saturated by water. When handling sieve beds, one must always make sure that they are tightly sealed with the end caps or with a piece of pipe or a piece of tape. For the same reasons explained, you must always handle zeolite in a room with less than 50% of humidity. This is one of the things that causes it to form lumps, which reduces the surface area of the zeolite, since the air cannot penetrate the lumps. This in turn also reduces the oxygen purity produced by the concentrator. Thank you, Moy.
Thank you very much, Masofa, for that explanation. I hope that will help to answer your question. And if you have some follow-up questions that you'd like to make, you're always welcome to raise your hand, or you can just paste it in the chat and we'll respond to those follow-up questions. Right. So moving on to our next question. So the question says, I am a maintenance supervisor of a certain district hospital. Just recently, our local electricity supplier communicated that we will be having more frequent blackouts. We have airsafe intensity 10s in our isolation unit, so I wanted to know how many concentrators I can run using a 2.8 kVA genset for the isolation unit. So I will ask Daphne to respond to this one.
All right. The first thing to know is that you cannot run at full loads for a long period and that it is always a good practice to leave a margin of safety. For more accurate results, refer to the nameplate data on your oxygen concentrator. An air-step intensity concentrator draws a maximum of 3 amps and at 220 volts AC. That means the power demanded by one air-step intensity is 660 volt amperes. And if you have 4 of these concentrators, they will all demand 2640 volt amperes at the same time. Another thing to keep in mind is that you're not supposed to operate a generator at its maximum power output for more than 30 minutes. So looking at the load of 4 concentrators and that you may have to run these concentrators for more than 24 hours, since it's the isolation unit, it is safer to run 3 air-safe intensity models with the 2.8 kVA generator for maximum efficiency so that you do not stress the generator. Thanks, Maui.
Thank you very much, Daphne, for that response. I hope that gives you a direction of how to handle that situation. So power can really mess you up if you are not very careful with it. So please just follow the recommendation that we've just given you, and hopefully that is going to work out well for you. All right, so moving on to our next question. So our next question says, I am working on a Dvubis 525 oxygen concentrator, which I plug into, when I plug into the main socket, the reset switch on the concentrator trips and the concentrator does not turn on. How do I deal with such a problem? So I will ask Linda to respond to this one.
Thank you, Maui. Every oxygen concentrator has a circuit breaker, which is labeled as a reset button on its front panel. And the main function of the reset button is to protect the electrical circuits from overload. Thus, when any component inside the concentrator, for example the compressor, is drawing more electrical current than it is supposed to, the reset button trips to automatically switch off the concentrator. In some circumstances, the reset button may trip due to poor mains power or when the button itself is faulty. And there are a number of things that you have to do in order to solve this problem. Firstly, you have to check the quality of the mains power if it is up to standard as given by your local electricity supplier with a digital multimeter. Then you also have to check all internal electrical connections of the concentrator to make sure that you don't have any short circuits. And also you have to check the compressor's electrical integrity. A simple test check would be to replace the compressor with a working compressor and see if a reset switch trips or not. If all of the above mentioned seem to be okay, then you have to check the PCB's electrical integrity by disconnecting the mains power and removing the control board from the concentrator. Then you have to look for any short circuits on the control board using a digital multimeter. So if all the above mentioned suggestions check out, you have to check the reset button's electrical integrity as well by replacing it with a working reset switch and check if the problem persists or not. So the images in the graphics are just showing the reset buttons which you are going to find in different concentrator models. Thank you, Maui.
Thank you very much, Linda, for that explanation. I hope that was clear for everyone else. But in case we have some questions or comments that we'd like to make, we are always welcome to ask those questions or make those comments. So we have a poll at the end of this question. So I'm afraid if you would please launch that one up.
Yes, I will. And while I'm doing that, Maui, do you want to just explain how to access the polls?
Yes. So if you are joining us from your mobile phone, if you go to the bottom right of your screen, there is a menus option. So if you click on the menus option, a window opens up where you have a couple of buttons there, and one of the listed buttons is the activities button. So if you click on the activities button, it's going to open up another window where the pause menu is one of the options listed. And if you are joining us from your computer, if you just go to the far right of your screen, there's an icon there, which is the activities button. So if you just click on that one, it will open up a window where the pause menu is one of the options listed.
Thanks, Maui. So our first poll question is, have you ever come across an oxygen concentrator with a reset button which keeps tripping? And we have a few votes in, but we'll give it another 30 seconds to see what else people have to say. Right now it's looking pretty even, where some people have seen this and others have not. All right, Maui, back over to you.
All right. Thank you very much, Amapri. So moving on with our questions. Our next question says, I have recently been employed by a certain mission hospital, and I have come to a realization that some models like the AirSep have an equalization valve, while some models like the DVBs do not have. I would like to know the purpose of the equalization valve. So I will ask Daphne to respond to this one.
Thanks, Maui. So it is true that some models of oxygen concentrators have an equalizer valve. To understand the purpose of the equalizer valve, we have to go through the cycles of the AirSep intensity model. So the AirSep model has 5 valves, and these 5 valves are the equalization valve, the left feed valve, the left waist valve, the right feed valve, and the right waist valve. 2 valves are always open at a time, and as the sieve bed, let's call it A, sieve bed A gets fed with air, sieve bed B gets depressurized to release the nitrogen from the sieve bed. After some seconds, sieve bed A gets saturated with nitrogen, and now the sieve bed B has to be fed. But before sieve bed B starts to be fed, the pressure from sieve bed A is shared to sieve bed B, so that when feeding sieve bed B, it doesn't start all the way from 0 psi. When the equalizer valve is on, the pressure is shared between the two sieve beds. That means if the pressure was 30 psi when sieve bed A was being fed, the pressure in the two beds would be 15 psi. The equalizer is on for a period of 2 seconds. After that, the equalizer valve closes and the waste valve for sieve bed A is turned on. The equalizer valve is also known as the pressure equalization valve because what it actually equalizes is the pressure in the sieve beds. But other concentrators, like you mentioned, the DeVille do not have equalization valves. Instead, they have an orifice, which is a small opening that restricts the flow of air. There is no equalization in the DeVille. Instead, the orifice is used for purging. And purging is the process of using oxygen-enriched air from sievebed A to flex out residual nitrogen from sievebed B after wasting. Thanks, Maui.
Thank you very much, Daphne, for that answer. I hope that was clear and you got your answer from that. But in case if we have some questions or comments from the audience, we are always free and welcome to make those questions and comments. All right, seems we do not have any questions there, so we'll be moving on with our questions. So our next question says, I would like to know how the double wobble compressor inside an oxygen concentrator works. So I will ask Linda to answer this one.
Thank you once again, Maui. The double warp compressor of an oxygen concentrator has four main parts, which include the head gasket, two valve plates, the piston, and the motor. As you can see in the graphics, those are the parts that I've mentioned. So these parts work together with some subparts to pressurize air for nitrogen adsorption. Each valve plate has two one-way valves, which are also called flapper valves, and the head gasket is divided horizontally, with one side being the inlet and the other side being the outlet. When the piston moves down together with the piston cap, it creates a negative pressure, thereby sucking air from the outside. The air gets pulled into the cylinder sleeve through the inlet via the one-way valve on the inlet side. The one-way valve on the exhaust side prevents air in the exhaust path from being dragged back. And as the piston cap moves up, the one-way valve on the inlet side prevents the air in the cylinder sleeve from going back into the inlet. Rather, this air gets directed to the exhaust via the one-way valve on the exhaust side. And for a 50 Hz electrical outlet, this process that I've explained happens 50 times in a second. And this makes the compressor achieve the required air compression necessary for sieving nitrogen in the sieve beds. So for a more detailed explanation on how a double warp compressor works, you can find a link which will be pasted in the chat explaining more about how a double warp compressor works. And this was covered as one of the topic of interest in our previous concentrator talk course. Thank you, Maui.
Thank you very much, Linda, for that response. I hope that helps to improve your understanding on how the double wobble compressor works. So we have pasted a link in the chat of the Oxygen Alliance website. There you'll find all the videos and recordings of our previous sessions. And there you also find the explanation on how the double wobble compressor works. So if you need more details or if you missed something, just go and watch the video, and hopefully that will help to clear out any further questions that you might have. Right, so reaching this far, we'll take a slight diversion from our questions, and we will now move on to our topic of interest. As I explained at the beginning, today we'll be discussing about what not to do when you're working with an oxygen concentrator. So Francis is going to take us through that explanation. So over to you, Francis.
Thank you, Maui. So as Maui already pointed out, today we'll be going through the do's and don'ts. Yeah, so this is what you're not supposed to do, and also at the same time what you're supposed to do when you're using an oxygen concentrator. So oxygen concentrators are used for therapy, that is oxygen therapy, and must be handled and used appropriately to ensure that they serve us with the needed oxygen. So for these oxygen concentrators to continue to function at their full capacity and longer periods of time, we have to make sure that we do certain things, and some of the things are the things that we'll go through in this topic. So we start by where you're supposed to use it, or how you're supposed to place it, or placement in short. So oxygen concentrators use ambient air to sieve out nitrogen and give out the much needed oxygen. That being said, since they use ambient air, oxygen concentrators should be placed at least 30 centimeters or 1 feet away from the wall, because they need enough space to circulate the air, and because they tend to get hot upon continuous use. So if you place it too close to the wall, the ore might also get hot. Might not necessarily be a ore, might be some metallic thing that surrounds that is closer to the oxygen concentrator, so might also get hot, and in turn the oxygen concentrator will also get hot and it will start to underperform. So you're supposed to place it at least 30 centimeters or 1 feet away from the wall while using it. Uh, that also being said, you should make sure that the room you're using the oxygen concentrator in is well ventilated, so that air circulates into and out of the room, so that you always have a supply of fresh air for the oxygen concentrator to work on or work with. You should also make sure that the concentrator is at least 150 centimeters or 5 feet away from heat sources. So the heat sources might be such as heaters, for example, in hospitals. And if the oxygen concentrator is being used for home oxygen therapy, you should make sure that it is also away from heat sources in the homes, which might be gas stoves, candles, or also heaters, gas heaters, or something like that. So do not use an oxygen concentrator in rooms heated by paraffin or portable gas heaters. This will later be explained, as this is also you're risking the start of a fire. So prior to using your oxygen concentrator, you should make sure that it has all filters in place and that they are clean. Uh, that being said, you are not supposed to use an oxygen concentrator if the gross particle filter is weight, like it is damp, something like that. The air filter should be monitored more closely in environments where with abnormal amounts of dust and lint. So I said that you're not supposed to use it with or without the gross particle filter. You're not, if you don't have a gross particle filter, you're not supposed to use a mattress as well, a foam mattress as well as a replacement for the gross particle filter. The best solution is for you to have a replacement gross particle filter. But then if you don't have that, you can either use a piece of gauze. So it doesn't have to be many pieces of gauze, just 2 or 3, it's enough, just to make sure that they it traps the dust. So in extreme environments where you have a lot of dust in the area, if you use it without, or if you use it with a filter, of course, just because, but then because the environment is extreme or harsh, the bacterial filter, the air intake filter inside, the intake filter will prematurely occlude, uh, causing a decrease in the performance of the unit itself. So if you're in a harsh environment, you should make sure that you wash the gross particle filter almost every day. So I guess in this case, it would be right to just have a spare gross particle filter, so that while you're washing the other one is in place of the dirty one. So in the graphics, we can see a picture of the much said gross particle filter labeled as the air filter. So that's the gross particle filter we're talking about. And if you're using a humidifier bottle, you should make sure that the bottle is clean and that the water is fresh. So if you're using tap water, make sure that you try to drain out the water each and every day. And if you're trying to change a patient in between patients, you also drain the water and also clean the dehumidifier bottle thoroughly. But then if it's on one patient, you're supposed to, if you're using tap water, you're supposed to drain each and every day, and you clean the humidifier bottle thoroughly weekly. Um, Also, you're supposed to thread the wing nut located on top of the humidifier bottle to the oxygen outlet port, so that it is suspended. And also, you should make sure that it is securely tightened, because if it is not secure enough, what happens is that you set your flow at 5 liters per minute, for example, but then the patient doesn't end up getting the 5 liters per minute just because some air is leaking. So you should make sure that you don't have any leaks from the outlet port of the oxygen concentrator to the nasal cannula itself. On powering the oxygen concentrator, you are supposed to power it directly from a wall socket. This is so as it draws a lot of power. It needs a lot of power to function. So you should not use an oxygen concentrator on an extension cord, just to also evade the risk of fire. And prior to use, if you have the time, you're supposed to wait for about 10 minutes, as it takes a little while for the device to concentrate to almost pure oxygen. It's not that the same moment you turn on the oxygen concentrator, you get the pure oxygen, the almost pure oxygen that you're looking for. No, so it takes a little bit of time. And now we'll proceed to look at the things that you're supposed to do while using the oxygen concentrator itself. So the first thing is that you should avoid smoking or having an open flame near an oxygen concentrator. So oxygen itself isn't flammable, but then it supports combustion and risks the start of a fire. So you're not supposed to have to be smoking around an oxygen concentrator or have an open flame near the oxygen concentrator. No. Failure to observe this can result in either severe fire and or property damage and or cause physical damage or even death itself. So yeah, fire is actually bad, so you should try to avoid it. So we should know that even a small increase in the oxygen level, up to 24%, can create a fire hazard. So if you're working with an oxygen concentrator has the ability to go up to 95.6%. So you can see that the risk is much higher when you're using an oxygen concentrator, because 24 is not far away from 21%, and room air contains 21% of oxygen. So that's why you're supposed to take caution when you're using this equipment. So in an oxygen-rich environment, materials will become easier to ignite and fires will burn hotter and more fiercely than in normal air. So you're trying to prevent that. That's why you're not supposed to use it in an open flame or be smoking around it. So if you do smoke, maybe you turn off the machine and then, yeah, go smoke somewhere else. And for dual flow oxygen concentrators, make sure that if you open both flow meters, the cumulative flow does not exceed the maximum rated flow. So for example, if you're using a 5-liter oxygen concentrator and want to open both flow meters to supply oxygen to, let's say beverage, make sure that both flow meters don't go above or exceed 2.5 liters of oxygen flow. So you can either you can use any other combination that you want to, but then the cumulative flow shouldn't exceed the maximum rated flow. So if it's a 5-liter, you can open 2 liters on this other flow meter, and on the other flow meter, you're not supposed to go above 3 liters per minute. So the total flow shouldn't exceed 5, because the moment you start exceeding 5, you get underperformance. So you might even go as low as 60% oxygen purity. So you're not getting the desired oxygen purity that you want for the oxygen therapy itself to be effective. So you're also not supposed to T2 the two outputs of the dual flow oxygen concentrators to get 10 liters per minute of oxygen, like as shown in the graphics. So let's say you want 10 liters to supply to maybe, let's say, a COVID-19 patient. What you should do in that case is that you should just get another oxygen concentrator, preferably of the same model, because of output pressure. Anyway, so yeah, you're supposed to close the if, for example, as for the concentrator shown in the graphics, you're supposed to have the other flow meter closed and open only 1 to 5 liters per minute. And if the other concentrator also has 2 flow meters, you're also supposed to close one and open the other flow meter up to 5 liters per minute. And then you T the two outputs, the ones that are open, and then you use that, you supply that to the nasal cannula and then to your patient, and not use it as shown in this diagram, because you're not getting the oxygen that you need for the therapy, as already said. So that's what you should do. And the recommendation on this would be that to prevent this misuse of oxygen concentrators with dual flow meters, frequent user trainings are required to be done so that the users are aware that they're not supposed to do this. And mostly these concentrators just come in 2 flow meters for that reason, that maybe they might be used on another patient. Let's say, for example, you just want 5 liters on one patient, and you want 5 liters on another patient, but your concentrator is a 10-liter output. That's why they do it, but not necessarily that you should open both flow meters to the maximum flow. No. Another thing that you're not supposed to do is you're not supposed to use oils or greases or any petroleum-based solvents or cleaners on or near the unit. So you're only supposed to use materials that are compatible with oxygen. This is so as oils, greases can react explosively if they come in contact with oxygen at high pressure or high temperature. So you're also trying to evade the risk of fire in here. So that's why you're not supposed to use oil or grease or anything that is petroleum based. So that means to say, if you're also a patient, you're not supposed to use any petroleum based lotion on your face, because in case of fire, your face might also burn. Yeah, so yeah, to run away from that, that's what you must do. And when you are maybe servicing a concentrator and then you find that the capacity is 40, what you're supposed to do is that you are not supposed to touch the terminals of the capacitor, or allow metal objects to come in contact with the terminals of the on the capacitor. This is so as the capacitor can retain a dangerous charge level for several days after the unit is actually turned off. So it's not that once the unit is turned off, the capacitor gets to be discharged. No. So for you to avoid being shocked, you're not supposed to, to touch the terminals of the capacitor with bare hands. So it is always a good practice to do repairs while wearing gloves, to also try to evade some of these risks. Um, Moving on, when you're using a flow splitter with an oxygen concentrator, so might not necessarily be with an oxygen concentrator, might also be with an oxygen cylinder. But then in this case, if you're using the flow splitter with an oxygen concentrator, you should make sure that the flow on the oxygen concentrator is at least 1 liters per minute more than the total requirement from all the ports that are in use on your flow splitter. If you're trying to get 3 liters per minute from your flow splitter, you should make sure that the flow meter on the oxygen concentrator is set at 4 liters per minute. This is what the statement is trying to say. So what you're trying to run away from here is that if you set the flow meter on the oxygen concentrator at 3, and you're also trying to draw 3 liters on the flow splitter, what happens is that you don't necessarily get the 3 liters that you want. As you try to adjust one flow knob, the other flows also get to readjust. So you're just trying to chase like an endless thing, but then you're trying to run away from that. That's why when using flow splitters, you should always set it. Um, you should always give it that +1 buffer, so that you work well with it. You should also make sure that when you measure the period of oxygen being produced from a new, you should make sure that you measure the period of oxygen being produced from a new equipment before you commission it. So every time you get a new equipment, you should measure the purity of oxygen before you commission it into the wards, just to make sure that you certify that it, even though it's new, it has come in good condition, because sometimes factory faults do happen, and sometimes just because it's new doesn't mean that it's performing. Yeah, so after commissioning it, you should make sure that you do frequent purity checks to make sure that the equipment is also performing fine. So for the purity checks, the recommended purity check period is every 90 days or 3 months. But the more frequent you can do the purity checks, the better, because that just ensures that you're always up to the standard, the required standard. And also, when doing the purity checks, you should make sure that you test the equipment at the maximum rated flow. So if it's a 5-liter oxygen concentrator, you're not supposed to test it at 3 liters per minute, but rather you're supposed to test it at 5 liters per minute. And if it's a 10-liter oxygen concentrator, you also test it at 10 liters per minute, not necessarily at 5 or 2, because it might perform at 2, but then it's not performing at the maximum rated flow. And you always want it to perform at the maximum rated flow, because that's how it's supposed to be. The last thing that you're supposed to do is that when operating oxygen concentrators outside, you're not supposed to operate oxygen concentrators outside of their operational temperature specifications, as that can limit the concentrator's ability to meet the oxygen concentrator specifications. So every equipment does has an optimum temperature in which it performs best at. So even if the temperature is too low, or even when the temperature is too low, or even when the temperature is too high, it might start to underperform. Because so one thing that you should know is, even in extreme cold, the compressor won't start. So everything needs to be performing in the right in its required temperature. So for you to get the required temperature that an equipment is supposed to performing, in this case, the oxygen concentrator, you're supposed to refer to the specification section of the service manuals for the temperature limits. Coming this far, this brings us to the end of our topic of interest today, and thank you. Over to you, Mom.
Thank you very much, Francis, for that topic. There's a lot of information that has been shared there. A lot of things that we must not do, and how we are actually supposed to do them. So if we just follow these steps, then we will help to prolong the life of our devices. So if we have any questions on the topic that Francis has just presented to us, we are welcome to ask those questions. You can either just come off mute, or you can just paste it in the chat and I'll read it out and Francis will respond to it. So I see we have a question asking about access to the presentation. Okay, I see Amapri has already responded in the chat. So yeah, just wait for the email and then you get it. So we also record the course, so you can also go on to our YouTube channel and you should be able to go back and listen to the presentation again. All right, so moving on with our questions.
So Maui, there's a question in the chat.
Okay. Yeah, so we have a question from Augustus. He says, is it proper to share 5 liters per minute to 2 patients who need 3 liters per minute? Francis, do you want to respond to this one?
Yes. Okay. So I'm guessing in this case you're trying to use the flow splitter, but then okay. So if you're trying to use the flow splitter, if you need to share 3 liters per minute each to 2 patients, that means you actually need 7 liters on your oxygen source. So it's not possible if you have a 5-liter oxygen concentrator. But then with the 5-liter oxygen concentrator, you just be limited to sharing to 1 person. That's all. But then if you had a 10-liter or an 8-liter oxygen concentrator, that would be possible. And what you do is you would set your flow at 7 liters per minute on the oxygen source, in this case being the oxygen concentrator. And then on the flow splitters, you set it at 3 liters on the 2 flow split on the 2 flow meter outlets on the flow splitter. That is. So it's not possible in your as you've asked.
Okay, great. Augustus, I hope that answers your question, unless if you have another follow-up question to that. Okay, great. All right, so now to get back to our questions. So our next question says, I am a technician at a health center. While conducting oxygen concentrate assessments in the wards, I came across a 525 DVOBIS concentrator that was producing low purity. With the compressor kits worn out after opening it at the maintenance workshop. After checking the Hobbs meter, it showed that the machine has been running for longer hours than shown in the manual and needs to be serviced. But to my surprise, the concentrator's service LED was not lighting up and the buzzer was not beeping, and the nurses were still using it since there was no sign of malfunctionality of the machine. What could be the problem and the solution? So I will ask Paulina to respond to this one.
Thank you, Moabi. Thanks for the effort on trying to keep the medical equipment in good shape. It's obvious that the worn-out compressor kit needs to be replaced with a new one. That will enable the compressor to work to its best. Generally, the zeolite has to be changed for maximum quality output as well. With the light emitting diodes not illuminating, firstly check the connection on the PC board, since there might be a loose connection with the OSD cable. If there are any loose connections, please secure the connection and the LED will illuminate. If the situation does not change, the problem might be with the PC board, so you are advised to change the PC board. For the buzzer not producing a warning sound, this may happen if the buzzer is defective. The component is replaceable. Try replacing it with a new one. If that doesn't work, there might be a need to change the PC board as well. Thank you.
Thank you very much, Paulina, for that response. I hope that's helped to answer your question. In case we have some questions from the audience, we are free to ask. Yes, Francis, I thought I saw a hand. Go ahead.
Oh, I was actually trying to find out that we have a question. I think it's still on the floor splitters, or from Newaha Dan.
There is another question.
Oh, it's already been answered. Yes, there was.
I see. Dan, has your question been answered in the explanation that was given, or we need to explain further maybe before we proceed?
Oh, I don't know if I'm clear, but I wanted to inquire. My name is Noah Dan, and I'm coming in from Uganda. I wanted to inquire on that very part of splitting oxygen. If you have an oxygen concentrator that provides 10 liters, does that mean that you cannot supply oxygen to two patients who need 5 liters each? Because from the explanation, it looks like you have to have an extra 1 liter. If you're to provide, for example, 5 liters to two patients, you must have around 11 liters. I don't know if that is right. Thank you.
Thank you. You want to respond to us?
So yes, Dan. Okay, that's what the point says, and you got it clear. So if you're trying to supply, the problem that happens is that when you have a 10-liter oxygen concentrator and then you using a floor splitter to split the 10 to maybe 2 to 5 and 5, is that you don't necessarily get the 5 on the other floor splitter, on the other floor meter of the floor splitter. No. So the thing is that when you're trying to run away from that. So I don't think it's possible. So basically what you've said is true. If you want to supply 5 liters to two patients, you actually need an 11-liter source, oxygen output source.
Maybe just to add on to Francis' explanation, normally you get some pressure drop because of the length of the cannula. So if you are using a very long nasal cannula, you get a bigger drop in the flow. So that's why you are supposed to have a device that is supplying a higher flow, so that if you subtract that extra flow that you lose through the pipes, then you still be within range. Amakri, you also want to add on to that?
Yes, I actually wanted to ask Kulwinder to comment on the flow splitters, because we've done quite a bit of testing on it, and I think it depends a little bit on, as you mentioned, the different connectors and the length of tubing that's being used as well. So Kulwinder, can you comment on this?
Yeah, please. Thank you. In India, we have done this so many times in the Corona times. We have splitted the oxygen by using the Y tubes and the connecting tubes to different patients. We have connected even 4 concentrators of 5 liter with one output to combine the oxygen output. So if we are combining the 4 5 liter oxygen concentrators with a Y tube and the connecting tubes, so the output we made was nearly 18 liters. So 2 liters was lost in that, but the pressure and everything was okay. Uh, and the cannulas to be used mostly in these cases should be nearly 7 feet, I think. So they are more good for that. Yeah.
Thanks, Kulwinder. So I think maybe we should discuss this in more detail on a topic of interest in the following weeks. But I think it really does depend on the concentrators that you're using and the setup that you have to do the splitting. For example, Niwaha, I think in Malawi, you use in Uganda, you're using a lot of the DeVilbiss 10-liter concentrators, which have a much higher pressure of oxygen that they deliver. So you may be able to get, with a Y splitter and shorter tubes, you may be able to get to patients on 5 liters of oxygen or very close to. So that might be some testing that we want to do at the Auction Alliance, and then we can share the results with you, because different concentrators do work a little bit differently, especially with the pressures.
Okay, great. I don't know if we have any more comments on that, but as Amaprit said, I think we need to cover that in more detail. So please just make sure you join us for our upcoming talks, and then we'll be able to clear up all the other questions that we might have. All right, so moving on with our questions. Our next question says, we purchased 2 oxygen concentrators 2 years back, one named Perfect O2 and the other named Platinum 5 by Invacare. We started using the Perfect O2 continuously for 1 year. It worked fine, and after 1 year, we started using the other machine named Platinum 5 and kept the Perfect O2 in store. Now, after 1 year, we started using the Perfect O2, but the machine started giving low purity alarm with a yellow LED indication. What can be the reason? So I will ask Kowinda to respond to this one.
Thank you, Mwabe. So, as we know, the oxygen concentrator sucks the air from the atmosphere and separate nitrogen from air and gives concentrated oxygen. During this process, dust particles, humidity, and also enters the machine. Now, when the machine is in continuous use, it keeps on passing. But when the machine is not used for a long time, and the humidity and dust particles stays in the seabeds and contaminates the sea material present in the seabeds. So this causes the problem of low purity as indicated in your case. We will suggest never store the machine for a long time. At least turn it on for at least 2 hours within 1 week, which will help in flushing out some moisture that may have started to accumulate inside the concentrator. Frequent use of concentrators will prolong the lifespan of the seed material, and less frequent use makes the seed material contaminated very frequently. So in this case, the seabeds used in both the machines are also different. In Perfecto, the size of the seabeds is much smaller, as in case of Platinum 9, the size of seabeds is double. So that may also matter. So we should use the machine at least 2 hours within 1 week. Thank you.
Thank you very much, Kowinda, for that response. I hope that helps to answer the question that you had. But in case we have some follow-up questions or some comments that would like to add on to Kowinda's explanation, we are always welcome to do so. All right, it seems we do not have any questions there. So moving on to our next question. So the next question says, we have been using one Oxypure oxygen concentrator for the last 2 years in the ozone generation plant for water purification. The machine worked fine as we kept the filters changed at regular intervals. Now the machine started heating up much more than normal. On testing, we found the machine was producing a purity of only 25%, and the machine shuts down after 2 minutes. What can be the reason? So I'll ask Kowinda again to respond to this one.
Thanks, Bobby. So as you mentioned in the question, the machine is used for water purification. So normally the humidity in such cases may be much more, Now, in the case, we have to find the reason for heating up of the machine. Now, in the working of an oxygen concentrator, it sucks air and passes the air into the sieve material, which filters nitrogen. Now, in this case, the sieve material may be much more contaminated as it does not let the oxygen to pass through it and causes back pressure, causing the heating of the machine. At the same time, the temperature sensor senses high temperature and the machine is shutting down. So to overcome the problem, you have to change the sea material, or we have to replace the complete seabeds of the machine to overcome the problem. Thank you.
Thank you very much, Kowinda, for that response. I hope that explanation was clear for all of us. But in case we have some questions or comments, as usual, we are welcome to make those comments. All right, it seems we do not have any questions or comments there. So we'll now be moving on to our final question of the day. So the question says, I was working on a DeVilbiss 515 concentrator that was registering 46% oxygen purity. I serviced the compressor, refilled its sieve beds with new zeolites, checked for leakages, but the purity only changed to 82%. After checking for leakages, I was surprised to see the valve block leaking badly despite being tightly screwed. What are some of the repair techniques I am missing and how can I address this issue? So I will ask Paulina to respond to this one.
Thank you, Mobi, for the question. It is very important to be doing preventative maintenance sessions on medical equipment time and again. This ensures that the medical equipment is in good shape to save lives. Sieve beds refilling and compressor service are indeed important areas that need to be checked on when servicing oxygen concentrators. If the purity increased from 46% to 82%, this simply means there are high chances of getting maximum purity if you take much of your time sealing leakages. This is a crucial part that could be easily missed. Take out the solenoid valve from the concentrator. Open the solenoid valve block by removing the 3 screws. The graphic on the screen shows the solenoid valve before and after it is opened. After opening the block, you will see that there is a gasket between the 2 separated covers. Once the gasket wears out, it cannot manage to restrict air from escaping. In your scenario, it is advisable to replace the old gasket with a new one if it's locally available. If it's hard to find one from the market, you are advised to use a thread tape as shown in the graphics. After adding the thread tape, put back the gasket and close it tightly. Surely that is the way to deal with the leakage on the solenoid valve block. Thank you, Mabi. I hope this will help. Thank you.
Thank you very much, Paulina, for that response. Indeed, I hope that's going to help to solve that issue. But we have done this here before, and it has proven to be helpful. So hopefully it's going to work for you as well. So we also have a final poll at the end of this question. So Amapri, please launch that poll.
Yes, and our poll question is, have you ever had a scenario where the solenoid valve was leaking? And we'll give it a few minutes for people to answer that question. And while we are, there was another question in the chat, Mwawi, from Augustus saying, I think the O2V must have accommodated some dust on the air inlet filters. Wash the filters and dry them, put on the machine and leave to allow it to run for 5 minutes. I think this was in response to the OxyPure question about the ozone generation. But if there are any other questions or comments or response to Augustus's point, we can answer that as well.
Okay, great.
Augustus, did you want to add something to that? I think it was just a comment about filters, which I think we talk about a lot, the importance of changing and cleaning out filters. Okay, so then for our poll question, it seems like most of our votes are for yes. Solenoid valves have been leaking, and this is a common problem.
All right, great. It would be interesting just to know what some of you did in order to fix that problem. I think we still have a minute, so maybe you can just share with us what you did in order to fix that issue when you faced it. So you can just come off mute and then explain to us what you did. If the solution was similar to what Paulina has just presented to us here. Okay, seems we do not have further comments there. All right, so reaching this far, this now brings us to the hour mark, which brings us to the end of our call today. I'd like to thank you all for joining us for the call. A huge thank you to all of you who participated. We always encourage you to participate in these calls. So it's not just about us sharing the answers to the questions that we have got, but if you have a comment, you're always free to ask. So for those of you that are joining us for the first time, we always encourage you to share with us your email address. So you can do that by pasting in the email address in the chat, and then we'll add you to our mailing list. So this will help you to sending you reminders of when the next concentrator talk call is going to happen, and also we'll be sending you updates to the different activities that are going on around with the Oxygen Alliance. So we also have a website and a YouTube channel. I think we'll paste the links in the chat. Please visit them and have a look at all the wonderful work that the Oxygen Alliance is doing. Hopefully that will be very helpful to the work that you're also doing in your different countries and hospitals. So reaching this far, if we do not have anything else, I'd like to wish you a great week, and we'll see you again in our next concentrator talk. Bye, everyone.